Okay, next I will explain about introduction. Rainfall is the volume of liquid water that falls as a precipitation over a certain area and time, typically measured in millimeters and inches. When talking about rainfall, so the precipitation is usually referred to as snow, hail, sleet, and rain, and drizzle. Rainfall can be calculated by collecting rainfall over a wide range of locations and hours because amounts may vary slightly between and times. Based on intensity, there are three different types of rain. The three types of precipitation are light rain, which is less than 2.5 millimeter per hour, moderate rain, which is 2.5 to 7.5 millimeter per hour, and last one is heavy rain, which is greater than 7.5 millimeter per hour. Uh, Convective precipitation and orographic precipitation are two types of rain depending on a lifting mechanism.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atira binti Muhammad Razi and my number matrix is AF210027. I will present the objective of this project. The objective of this project is to determine the mean area rainfall of the proposed catchment area. Second, to analyze the peak flow of the proposed catchment location and discharge of the river at the maximum water level. Third is to determine and plot the unit hydrograph for the proposed catchment area. The purpose of this project to establish the manual annual rainfall of the proposed catchment region, the peak flow of the proposed catchment location, and the discharge of the river at the highest water level using rainfall and water level data from the Sarawak Seri Aman station and the hydrograph unit. The planning and design of the water control system often make use of hydrograph or certain aspect of them, including peak rate. They are also used to show how proposed and actual watershed project and land use change may affect the hydrology.
For methodology part, we choose 3 rainfall station, which is Lingga, Nanga Entalau, and Nanga Tutong 2. The station that measure the water level is called Engkelili Batang Lupa, and the stations are all located in Sarawak Sri Aman district. Next, for method of collecting data for mean area rainfall, there are 3 ways to calculate the average rainfall, which is arithmetic mean method, Thiessen polygon method, and isohydrate method. While for calculate the hydrograph, using hydrograph station at each rainfall station from public info banjir, which is from station Nanga Entalau, Nanga Tutong 2 and Lingga, which is located in Sri Aman, Sarawak, we can obtain the hydrograph.
To calculate peak flow by using rational method, we need to identify rainfall intensity by using the formula I equal to lambda Tk over D plus angle and multiple with n. And then we substitute in the formula, but with lambda, k, theta and n is fixing constant dependent on the rain location. And after we substitute, we will get the answer 203.8933 millimeter per hour. And then the answer for I, we substitute for the formula peak discharge, which is the formula is Q equal to I multiple with C and multiple with A over 360, and we will get 30.5929 meter cube per second.
For the rainfall data, we using 3 methods of variable rainfall calculation, such as arithmetic mean method, Thiessen polygon method, and the last one, isohydrate method. For the first method, which is arithmetic mean method, we use this catchment area that we got from the Google Earth Pro. In this table, it contains the 5 days collected data rainfall from 3rd of October until 7th October 2022. To calculate the P, which is the average precipitation depth, we use this formula. This is a calculation which is P equal to 1 over 3 sum of the total rainfall for 3 stations in 5 days. For this method, we get 131.71 millimeter for its average precipitation depth. Next, for the Thiessen polygon method, this is a diagram of the Thiessen polygon. For this method, we have to find the area of each polygon station. The formula for this method is P equal to the sum of the area times the precipitation depth at each station over sum of the area. The result for this method is 134.56 mm. The last one is isohydraulic method. We have to find the isohydraulic interval and its area. The formula is the sum of the area times the average precipitation over the total of the area. The average precipitation is 129.04 mm.
Next, to find the cross section, we must determine the slope of stream. So the value of slope was obtained from the average of slope. So we get the value of slope is 0.016 from Google Earth Pro. Next, for the cross section downstream, we calculate the area and perimeter using perimeter triangle and rectangular, and for the other section we use area triangle and area rectangular for other section. Next, from area and perimeter we can get hydraulic radius, which is the formula is R equals to A over P, and we get 3.26 meter, and then using the manual equation we get 2,968.56 meter cube per second for the peak flow. Next, for the cross section at middle, we use the same formula, which is perimeter triangle, perimeter rectangular, area triangle, and area rectangular. We calculate the area and perimeter to substitute in the hydraulic radius formula, which is R equals to A over P, and then we get 2.91 meter, and for manual equation we get 2105.9 meter cube per second. For the last one, which is cross section at upstream, we calculate the area and perimeter using the area triangle formula and rectangular formula. Also for the perimeter, we use triangular and rectangular formula, and then we substitute the value of area and perimeter that have been calculated into the hydraulic radius formula. R equals to A over P, we get 3.23 meter, and for the manual equation we get 2901.77 meter cube per second.
Next, for hydrograph. A hydrograph is a visual representative of a discharge over time at any specific location. Time is shown on the x-axis and discharge is shown on the y-axis. When a watershed-wide amount of one unit, which is 1 inch or 1 centimeter of uniform, constant intensity rainfall occurs, a unit hydrograph. A direct run of hydrograph is rated. Okay, next is discharge of each cross section for 5 months at Batang Lupa. Okay, as you can see, this is the cross section at downstream. This is the cross section at middle. And the last one, this is the cross section at upstream. Okay, this is graph for hydrograph and unit hydrograph. This is the highest rainfall event. This is the second highest rainfall event for hydrograph cross section at middle and unit hydrograph cross section at middle. Okay, this is the third highest rainfall event for hydrograph cross section at upstream and unit hydrograph cross section at upstream.
Next, for discussion, the average depth of precipitation P for arithmetic is 131.17 mm, followed by the polygon at 134.56 mm to the study research. Additionally, the mean area of total rainfall that we estimate for 5 days is at Lingga, total rainfall is 148, at Nanga Antalau 129, and Nanga Tutongtu 116.5. By looking at the mathematical formula used to determine how much rain fell, this tactic works well if the location of each station is balanced. Add together all the data that was gathered, divide the total by the total number of items in the set, and you have your calculation. The arithmetic mean of an equally dispersed integer may be calculated using the middle number. The decent polygon technique is also known as the weights mean method. This strategy has the advantage of being quick to utilize for a spread of storm because it uses a present region. The isohydraulic approach is the most exact method since it requires skills and knowledge. The mean yearly precipitation may be calculated using this method by drawing a line a line of comparable precipitation over the district. Apart from that, the primary element of the study is hydrograph. It is simple for the researchers to discover the precise data when they refer to the runoff rate versus time graph. A stage hydrograph is a graph in which the stage is plotted against time, which is the form of a stream called record. A graph that plots the discharge versus time is called a discharge hydrograph. For the average rainfall rate, which is 203.8933 mm per hour, this will allow us to determine the Q, for which we had created a graph of Q versus time. As shown in the table below, we have a cross-section at downstream, middle and upstream. The value of Q is 2968.56, 2905.9 and 2901.77, and at the area 640.46, 490.08 and 629.92, and the parameter 196.39, 168.42 and 194.9. And last but not least, even the data that we collect and analyze contains some errors and inconsistencies, we are able to correct the error with the help of our instructor and the other group members, who work very hard to complete the assignment. Because it is an internet-based project, we may acquire information from a number of applications and websites. For example, Google Map Pro is quite helpful in completing the cross-section piece, figuring out how wide the river is and describing the area around the station.
For the conclusion, in this project, we use rainfall and water level data to determine the mean annual rainfall of the proposed catchment region, the peak flow of the proposed catchment site, and the discharge of the river at the highest water level. Hydrologic study of the precipitation amount and duration, peak runoff rate, and timing of the runoff from a given catchment region are all required for drainage structure development. Several methods were utilized to calculate the catchment area's peak flow. The unit hydrograph method produced the highest accurate peak flow prediction of any method tested. A unit hydrograph depicts the change in flow or the discharge over the time per access unit of precipitation runoff. The rational method forecasts peak runoff. As long as identical units are used, this method is applicable to either US or metric evaluation. The advantage of this method are the data relative availability and simplicity of use and minimal cost of the data collecting. That's all from us. Thank you.